All right, so difference quotient, f of x plus h minus f of x over h. This is a way that we will be able to find the slope. We won't be doing that in this class. All we're going to do is use it as an introduction. But when you get into calculus, you'll use it and use it for different applications. One of the ways, like I said, is to find the slope. When you're missing certain information the typical way, you can use this to find slope to a tangent line. But like I said, all we're going to do is talk about how can you find the difference quotient. And the way we'll do that is by using this formula right here, f of x plus h minus f of x over h. So notice when we look at our first example, they give us f of x. That's always going to be the case. They have to give you f of x. That is the function. Then from there, you need to find f of x plus h. So they give you f of x, but then you need to find f of x plus h. So you take x plus h and plug it into your function. So since we had 2x squared, that's 2 times x plus h squared minus x plus h plus 3. So don't forget, this square cannot be applied to x and h individually. You have to expand that. So that's x plus h times x plus h. And so when you FOIL that out, that gives us this, distributing your x, distributing your h. All right, and like this. So of course we distribute that negative, and that gives us this right here. 2 times x squared plus 2xh plus h squared minus x minus h plus 3. And then you do want to distribute the 2. So you want to fully expand out f of x plus h. And it gives us that. All right. Questions? Any questions? So we plugged in x plus h into our function, expanded it out. And now that we have f of x plus h, we can plug it into the formula. So you see f of x plus h minus f of x over h. So the blue arrow just pointing out where the minus sign is in the formula, where the minus sign is, and when we plug in the expression of the formula. All right. Any problems? All right. So we do have to distribute this negative. All right. And let me erase this. All right, so once we distribute that negative, that'll give us negative or minus 2x squared plus x minus 3 in the back. So now we can combine the like terms, and that's going to cancel out some things for us. 2x squared and negative 2x squared, negative x and x, and then 3 and negative 3. All right, make sure we're okay. So now when these things cancel, when these terms cancel for us, each term left in the numerator must have h still in it. If that doesn't occur, then somewhere we went wrong with our calculations. So notice that's 4xh plus 2h squared minus h, and all of that is over h. All right. So what's going to happen now is that this h goes into each, and we will be able to cancel out or reduce. And that'll leave us with 4x plus 2h minus 1. Mm-hmm.
I got a question.
Mm-hmm.
This is where I would get tripped up at. I would rearrange that top problem and factor.
You say you would factor?
Yeah, I would factor the top. That's why I get tripped up at. I get confused.
Okay, how would you factor it?
Factor out the H, right?
That's fine. So there's nothing wrong with that. Right? And then the h will cancel. And then that will leave you the same thing.
Okay.
Yeah. It's just that the 8, you wouldn't have to take the h into each term because you canceled it out right here.
Okay.
Yep.
When you did the H divided each one of those,
Mm-hmm.
it didn't register to me. I would have flipped the H, reciprocal and all that stuff.
Oh, yeah. Well, now remember, if you're going to start doing opposite, you have to have another side of the equation. Now, if you're trying to get rid of the h that's down bottom,
Mm-hmm.
if you're trying to multiply both sides by h, that what you're saying you're trying to do?
I don't know. I just remember I've been taught so much that I get certain things confused.
Gotcha. Gotcha. Yeah. So, well, I will say this. To me, this is the easiest way of handling this type of problem. Just dividing the h into each individual term and then canceling them out.
Like you preach factoring so much, it's stuck in my head. Sorry about that, y'all.
Any other questions before we look at least one more doing the difference quotient? All right. So the next one is not as complicated, but it's still worth doing. We have f of x is equal to 3x plus 7. Once again, if you're trying to find the difference quotient, then you need f of x plus h as well. So you take x plus h, plug it into your original equation, and expand it out. So we took x plus h, plugged it in for x, 3 times x plus h, that's 3x plus 3h plus 7. So we have f of x here and then f of x plus h here. Then plug it into the difference quotient formula. 3x plus 3h plus 7 minus 3x plus 7. And don't forget to distribute that negative.
So, Professor Tucker,
Mm-hmm.
so the simple way of doing this, like this upper part where f of x is given, and we have to find f of x plus h, is whenever you're solving for f of x plus h, just plug in f of x plus h where x is for f of x.
Yes.
Just remember that, and then after that, when you get a solution, then you can follow the formula where f of x is goes the solution, and we already have f of x.
Yes.
Okay.
Mm-hmm.
All right.
Yep. All right. So once you distribute, I'm going to erase this part. Distribute, that'll turn 3x negative and 7 negative. So now you can go ahead and cancel out 3x and negative 3x will cancel. And 7 and negative 7 will cancel. Remember, each term or any term that's left in the numerator should have h in it. In this case, it will just be 3h. So then 3h over h would be 3. All right. Questions? Any questions? All right. So let's look at the difference quotient, not the difference quotient, 2.3. That was it for 2.2. So now we're looking at 2.3. Looking at linear functions and the slope. So your slope is going to be represented by m. And we will calculate the slope by doing y2 minus y1 over x2 minus x1. Or we can do y1 minus y2 over x1 minus x2. No matter which way we do this, whether it's this way or this way, as long as we stay consistent. In other words, y2 is first on top, it means x2 is first on bottom. Or y1 first on top, it means x1 is first on bottom. Either way, and I'll show you, either way you use it, you still should get the same answer. And then we have rise over run all the way to the right. If we do rise over run, normally we use that when we're trying to graph, and I'll show you how to do that as well. So x1, y1 comes from 0.1, and x2, y2 comes from 0.2, and they just represent any 2 points that are on the line. Any 2 points on the line will help you to calculate the slope. Your slope is basically a numerical value for the incline or the steepness of the incline of your line, or the slant, or just like you think about the slope of a mountain, how steep it is. So we get a numerical value for that. All right. So looking at the first one, find the slope of the line passing through the points, -3, -1, and -2, 4. All right. So I call my first point -3, -1, second point -2, 4. Once again, it doesn't matter which one you call which, as long as you do it correctly, you'll still come up with the same answer. So I'm going to do y2 minus y1 first, x2 minus x1 on bottom. So my y2 is 4. Y1 is -1. Be careful. What I try to emphasize right here is make sure you watch your negatives. Don't lose a negative in your substitution. All right. So that's minus -1. And then same thing happens down bottom. I plug in -2 for x2, but then -3 for x1. Negative to a negative turns positive. So I have 4 plus 1 over -2 plus 3. Adding those together, I have 5 over 1, which is just 5. Now, if your slope ended up being a fraction, like in the next one we'll see, not this, next example altogether. If it ends up being a fraction, then you leave it in fractional form. You do not convert it to a decimal. This one is 5 over 1, which simplified as much as possible will just be 5. So that's why that turned into a number, a single number of integer. So now going over here, I'm going to use the same values, but I'm going to substitute in y1 first and x1 first down bottom. And when you do that, you notice you'll still get the same answer. So we have -1 for y1, 4 for y2, -3 for x1, and -2 for x2. Do the math on those. You have -5 over -1, which is a positive 5. So, like I said, just showing you whether you do your x2, y2 first or x1, y1 first in the formula. Either way, you'll come up with the same answer as long as you stay consistent in your substitution. All right, so before we go to another one, questions on what we did there? All right, so the next one, -3, 4, 2, -2. So plug in the values. Y2 is -2, y1 is 4, x2 is 2, y1 is -3. Well, x1 is -3, excuse me. And that'll give us -6 over 5. All right, questions? Any questions?
Do we simplify the fractions?
Nope. Well, you simplify them and make sure we're clear on what we mean by simplifying because everybody have different definitions. Not even saying that you think this way. I just want to make sure everybody's with me. So simplifying, the answer is yes. So if you're talking about if I have 4/6 and I'll break that up in because 2 is canceled and I'm left with just 2/3. That you are always expected to do. Some people would say simplifying, they think simplifying is either turning this into a decimal or turning it into a mixed number. So you will not do that. You will simplify your fraction, but you will not convert to a decimal or a mixed number. All right.
I got
So,
a question, Professor.
yep.
4 is the y-axis, 6 is the x-axis, right?
When you say 4, yeah, you're talking about right here and right here. Yep.
But wouldn't that change my slope when I change it to 2/3?
Nope, because what will happen is you will have a number here, you will go down 4/6. And if you went, so that's what, let me see, I do it like that, and you will have this point. But if I did the 2/3, you go down to, and you still have line, just be a shorter
Gotcha.
distance. So you would have went here versus going down here. You see what I mean?
I see it now.
Yeah, it would still give you the same line. It's just that you wouldn't travel as much distance.
Thank you.
Not a problem. All right, so our basic behaviors of our slopes. There are 4 basic behaviors of your slopes. And that is when you're reading your graph or following your graph going from left to right, if it goes up, then your slope is positive. If your graph goes down, your slope is negative. If it's a horizontal line, your slope is 0. If it's a vertical line, your slope is undefined. All right. Once again, you always follow your graph going from left to right. If it's going up, your slope is positive. If it's going down, your slope is negative. Horizontal line, your slope is 0. Vertical line, your slope is undefined. Yep.
I always get these questions wrong.
Which ones? You just follow it up. If it go up, it's positive.
Yeah, they're kind of confusing sometimes.
It's like, ask me if it's positive, if it's negative. I forget that you go from left to right. I get points for the solution, but I get it wrong for the lines.
I get confused on the horizontal and the vertical one. I'm like, okay, horizontal is undefined, vertical is 0.
I'm not
I just got to memorize it.
I'm not alone.
No, man. I keep telling y'all not on islands, man. Y'all not on islands. All right. I know somebody asked if I can keep the grass for a second. All right, you good? Now scroll up.
I'll be honest with you, Professor. If it
Uh-huh.
won't be 60, I wouldn't have a clue.
You said if it wasn't for NDE 60?
I wouldn't have a clue.
Well, we look, all things work together, right?
Sorry.
So let's look at this next one. So graphing using slopes. So remember I told you if we want to graph using our slopes, we would use that last relationship of rise over run. And your slope is actually going to be directions for us. So if it's positive, I won't go to that part yet. Your rise is going to be up or down. Your run is going to be right or left. All right. So it'll be directions for us. So your positive moves are going to be up and right. Your negative moves will be down and left. Give you a chance to write that down. All right. So, in other words, if I have the slope of 2/3, that's a positive 2 over a positive 3. So that means I will go up 2, right 3. Positive 2 over positive 3. Remember, your positive moves are up and right. So I'll go up 2, right 3. But then if I have a negative 10 over 7, I can handle that one of two ways. I always say just give it the negative to the top number. And you just, that'll be safe. That'll always be safe. But you cannot get the negative to the top and bottom. Remember, negative over negative is positive. So you would choose one. Either you go negative 10 over positive 7 or positive 10 over negative 7. So just like, your classmate brought up the other idea of, would you extend out too far? Would it change your slope? It will always work out to do things properly. If you go down 10, if your slope is right here, and your point is in the middle, and you go down 10, right 7, that'll put you right here. But if you go up 10, left 7, that'll put you on the other side of it. But it still will give you the same line. Once again, you just have to make sure you do the things properly. Like I said, don't give the negative to the top and bottom, because like I said, negative over negative is actually positive. So you just give the negative to one of the numbers and then make the other one positive. All right. So let's look at our slope-intercept form. Y equal to mx plus b. You ever have your equation solved for y? Your linear equation solved for y. That's considered being a slope-intercept form. And the number that's sitting in front of your slope in front of your x is going to be your slope. The other number would be your y-intercept. So the reason why I want to point that out is because a lot of times people will write the slope. In this case, they will write 2/3 x. And of course, that's incorrect. X is not a part of your slope. The slope is 2/3. It's the number that's sitting in front of x. That is your slope. So your slope was 2/3. Your y-intercept is -1. Same thing in that bottom one. We have y equal to -4x plus 3. Your slope is -4. Your y-intercept is 3.
It does seem like the quarterback wants to stay.
All right. Questions? Any questions?
Someone was saying something, Professor Tucker.
Oh, no, that was my phone. I pushed something by mistake. At least I think that was, unless you heard something I didn't hear. I think it was my phone, though. Yeah, nobody said anything. Yeah. All right. So let's use this information to graph.
Up. Could you scroll up just a little bit? I missed that example over there.
Let me
Just
know
give
when
me
you're
2
ready.
minutes.
Yep, let me know when you're ready.
I got to watch YouTube to figure out how to use this calculator.
I'm good. Thank you, Professor Tucker.
Not a problem. All right, so looking at graphing. Say if we want to graph y equal to 2/3 x minus 1. We already mentioned how if I have a positive 2 over positive 3, that means I would go up 2, right 3. And if that -1 is a y-intercept, then we remember we talked about intercepts already. That means x is always 0. X is always 0. So the coordinate of your y-intercept is going to be 0 and that number. So in this case, it's 0, -1. All right. Once you've established the given information and pretty much the instructions, first thing you would do, look at what I have here in the green. First thing you're gonna do is graph your y-intercept. And that's what we have right here. That's 0, -1. Now, use the slope to generate another point from the y-intercept. We do not go to the origin. Your slope is not a point. You go to the y-intercept, and from the y-intercept, you go up to right 3. And that's where our second point will be. That would be the line. All right. Questions on that? All right.
Could you just
Question.
hold it here for a minute?
Mm-hmm.
All right, thanks, Professor Tucker.
Not a problem. Not a problem. All right. So let's do it one more time. So we have y equal to -4x, -5x plus 4. Your slope is -5. Your y-intercept is 4. So as a fraction, that -5 is -5 over 1. So that's a -5 over a +1. So you go down 5, right 1, and our y-intercept is 4. So our y-intercept is right here. We graph that 0, 4, and then from that 0, 4, we go down 5, and then we go to the right 1. And draw your line. All right, questions.
Not a question. I just want to make sure I got it. Always get your y-intercept first before you plot your slope.
Before you use your slope to plot another point.
Okay.
Mm-hmm. All right. Is everybody good before we go to the next thing? All right. Point slope formula. Y minus y1 equal to m times x minus x1. So our slope is m, and then x1, y1 is any point on the line. All right. So the requirements of this line is a point and a slope. That's why it's called the point slope formula. So notice what we have here. Write an equation of the line that passes through the point negative 1, 3 with the slope of 4. So we look at what we have right here in the red, that's the given information. They give us a slope of 4 and a point of negative 1, 3. So be careful when you do your substitution. Don't forget that if I had a regular equation, y equal to 2x plus 1, the x and the y is still a part of my equation. So I'm not substituting in for x and y. I'm substituting in for x1, y1, and m. And I'm going to leave x as a part of my equation. So I do that. 3 goes in for y1, 4 goes in for m, and then negative 1 goes in for x1. Make sure you don't lose a negative in your substitution. So it's y minus 3 equal to 4 times x plus 1, because that negative to a negative will turn positive. If I do my distribution, that will leave me with y minus 3 equal to 4x plus 4. Then to finish solving, I will add 3 to both sides. And that equation will be y equal to 4x plus 7. All right, questions, any questions? All right, so let's do it one more time. Make sure we're okay. Write the equation of the line that passes through 8, 5 with the slope of negative 1/4. Erase some of this stuff. So we see right here the given information. Oh, my erase is still here. Sorry about that. Given information is negative 1/4 for our slope, 8, 5 for our point. All right. So plug in accordingly. 5 for y1, negative 1/4 for m, and then 8 for x1. Do your distribution of negative 1/4. And you're talking about negative 1/4 times that negative 8. So I did that right here. So negative 1/4 times negative 8 over 1, just multiply across, that'll give you a positive 8 over 4, which is 2. So now we're looking at this right here. Y minus 5 equal to negative 1/4 x plus 2. Now to finish the problem off, we'll add 5 to both sides. 5's cancel. And that gives us y equal to negative 1/4 x plus 7. All right, questions? All right. Okay, yep. Any questions before I go to the next thing? Make sure we're good.
I have one.
Mm-hmm.
Maybe I forgot how to multiply a fraction with that number. Negative 1 over 4 times negative 8. Can you just real quick show the step so I can copy it down?
Oh, yeah, it's right here in the purple. Right here.
Oh, that's in the purple. Hold on,
Yep.
let me just copy that.
Mm-hmm. Yep. So it's just 1/4 times 8. I wrote 8 as 8/1. Then all I did was multiply across that -1 times -8 up top, 4 times 1 down bottom. So that's 8/4. And 8 divided by 4 gave you 2.
8. All right, thank you so much, Professor Tucker.
Not a problem, sir. Not a problem.
I forgot that too, Professor.
Yeah, I forgot.
It's all good, sirs. It's all good. Let's look at a little bit of 2.4 and then we'll close it out today. So 2.4, more on slopes. Talking about parallel and perpendicular lines. So parallel lines, lines that do not cross or touch, that means your slopes will be the same. Slopes will be the same if you have parallel lines. Right. Perpendicular lines, they are lines that intersect at a 90-degree angle or create a 90-degree angle at intersection. And their slopes are going to be negative reciprocals of each other. And we'll talk about what that means in a second. But their slopes will be negative reciprocals. Parallel lines will have the same slope. Perpendicular lines will have slopes that are negative reciprocals of each other. All right, somebody needed that from parallel lines. All right. Are we good with parallel lines? Let's see. All right, cool. So that's perpendicular lines intersect at a 90-degree angle. Slopes are negative reciprocals. You can never assume that you have perpendicular lines somewhere. It has to be stated somehow, some way. In other words, that 90-degree angle can never be assumed. There has to be either some directions or that symbol that lets you know you have 90 degrees there. So once again, you can never assume that you have a 90-degree angle. All right, scrolling up. So let's make sure we're okay with what it means to be a negative reciprocal. Reciprocals are just flipping your fraction. So if I have 3/4, flipping that will be 4/3. So that's just a reciprocal. If I have -10/7, the reciprocal of that will be -7/10. Reciprocal of 5 is 1/5. Now, negative reciprocals means you would flip the fraction and use the opposite sign. Doesn't necessarily have to be negative, it just have to be the opposite. Negative mathematically means opposite. So if I have 3/4, the result or the negative reciprocal of that would be -4/3. -10/7, the negative reciprocal of -10/7 would be +7/10. Once again, you flip the fraction and use the opposite sign. And then same thing with 5. The negative reciprocal of 5 would be -1/5. So you flip the fraction and you use the opposite sign. That would be a negative reciprocal. All right.
So
Questions.
in the reciprocal, you don't swap the sign. If it's negative, it stays negative. But in the opposite, if it's negative, you turn it into positive and flip the fraction.
Right. And so that's what this relationship right here is what's asked of you when it comes to a perpendicular line.
Okay.
So I just want to make sure we were clear when someone say reciprocal, you don't flip the sign, you don't change the sign. But when they say negative reciprocal, you do change the sign when you flip the fraction. All right, so let's see how that translates as far as our slopes are concerned. So here I just have a little mini chart. If I have my original slope as 8/3, if I want a line that's parallel to the line that has this slope, that means the slope would be 8/3. Parallel lines will have the same slope. Now, if I have 8/3, but I want a line that's perpendicular to that, then it would be flipping the fraction and using the opposite sign. That would be a negative reciprocal. So once again, if I have a line that has the slope of 8/3 and I want a line that's parallel to it, then I have to have a line that has the same slope. If I want a line that's perpendicular to it, I will flip the fraction and use the opposite sign. Same thing occurs over here. If my slope is -9/11, a line that's parallel to that will still be -9/11. And then a line that's perpendicular to it will have the slope of +11/9. All right, questions? Any questions?
So when we get to a perpendicular line, there are two ways. Like there's a reciprocal and a negative reciprocal.
No, I was just saying that a reciprocal is just flipping a fraction.
Mm-hmm.
But I was just giving you basically, in this word, negative reciprocal is reciprocal. So
Mm-hmm.
I was just explaining what a reciprocal was, but then telling you, but what you need is the negative reciprocal.
Okay.
You know what I'm saying? Yeah. So yeah, there's only one way to do it, and it's negative reciprocal. But the negative is describing what the reciprocal is. So I had to tell you, I didn't want to make sure we were okay with what a reciprocal was, and then we're looking at negative reciprocals, not just reciprocals.
Okay.
Yeah. All right. So before we go to an example, everybody okay? All right. So let's write the equation of line passing through -3, 1, and is parallel to the line y equal to 2x plus 1. So we're going to write the equation of the line that's passing through -3, 1, and is parallel to y equal to 2x plus 1. All right. So we have our equation solved for y, so we already know what our slope is. Our slope is 2. Now, this is the original line, so this is our original slope, but we want a line that's parallel to this one. So we know our slope is 2. Now, the slope of a line that's parallel to that is going to be 2 as well. Remember, if it's parallel, it will have the same slope. All right, so is everybody okay with that? We have a line that they gave us. We want a line that's parallel to that one. So our slope is going to be 2 as well. All right. So now they gave us a point. It passes through -3, 1. So we now have a point and a slope. So we can use our point slope formula. Plug in y for y1. Plug in 1 for y1, 2 for m, and then -3 for x1. Add 1 to both sides. And y is equal to 2x plus 7. questions? Any questions?
Professor Tucker,
Yes, sir.
one is our y-intercept we plugged in.
You said no. No, it's not. No, this is a coordinate of -3, 1. A y-intercept. Now that's the y component, but the y-intercept would have had to have been 0, 1. If that's what you're talking about.
See, I
Remember,
would
for all y-intercepts, x is 0. So that's a whole point by itself, y-intercept. So you could say that the y component of this ordered pair was 1.
so the one that's from the ordered pair is what we plugged in there.
Yes.
Okay.
Yeah.
I got a question, Professor Tucker.
Yes.
When we're looking at original slope and parallel slope, they are always going to be the same. We don't change, flip flop, or anything.
Right.
Like, let's say here it's a slope of 2. Let's say we have a slope of -5/4. The slope, the parallel slope would be -5/4, right? We don't make the negative positive or
Right.
do it 4/5.
Right. Absolutely
And
correct.
if it's a perpendicular slope, then we change the negative to a positive and we do 4/5.
Yep, you got it.
All right.
Hmm. And that goes back to, just the nature of parallel lines. Remember, they're going to have the same incline because they can never cross each other. If anything's different or even slightly, eventually it would touch because they will cross. So that just goes back to the nature of what parallel lines are. They have to have that same incline, which would be their same slope. All right, so the next one is a perpendicular example. It says write the equation of the line passing through 3, -5, and is perpendicular to x 4y, x plus 4y, minus 8 equal to 0. Then also notice it says express in general form. And we'll talk about that when we get to the end, but always make sure you pay attention to the directions and what they're asking of you. So we need to take this equation and figure out the slope. Our last equation, the last original equation that they gave us was already solved for y, so we could just pick out the slope. So we need to take this equation and solve it for y first. So I subtract the x from both sides and added 8. What did I do? Give that back. Yep. So that'll give me that 4y equal to -x plus 8. Subtract x from both sides, add 8 to both sides. So they cancel on the left, leaving me just 4y on the left. -x plus 8 is on the right. I still want to solve for a y, so I'll go ahead and divide both sides by 4. And don't forget that 4 has to go into each term on the right side. So simplifying that gives me -1/4 x plus 2. All right. So that means our slope for this line is -1/4. All right. And a line that's perpendicular to that would be what your classmate just mentioned. You use the opposite sign and you flip the fraction. So we had -1/4. So we flip it to be 4/1 and positive. All right. Any questions so far? All right. So our slope is 4, and they gave us the point of 3, -5. Our line runs through 3, -5. So we have a slope and we have a point. So now we can plug them into our, didn't mean to use that. Plug them into our equation right here, our formula. y minus y1 equal to m times x minus x3, x1, say x3, because that 3 down there. So we substitute in -5 for y1, 4 for m, and then 3 for x1. All right. So that'll be y plus 5 equal to 4x minus 12 after you do your distribution. Negative, negative turns positive. So from there, subtract 5 from both sides. 5's cancel on the left, and it leaves me with y equal to 4x minus 17. All right, so remember it asks us to put our answer in general form. That's ax plus by plus c equal to 0. If you go back to the original, they actually gave us that original problem in general form. Just every term need to be on one side and set equal to 0 basically. So I subtracted y from both sides, and that'll be 0 equal to 4x minus y minus 17. All right. Questions? Any questions? All right, questions on anything? That brings us up to 2.5, so I'll wait till next class to get into 2.5. I think there may be something else I want to do with that, but we'll see. Any questions, concerns, comments? Anything, anybody?
Are we done with the class? Can we ask questions about the test?
Yeah, what you got?
I just wanted to ask if, like, if, like, the first time on the test you got a 90, and the second time you get less or like something less than a 90, well, would you take the first grade or the second one?
Oh, I always take the highest.
You take the highest grade?
Yep.
And if I retake the test, will the questions be same? I know it's a dumb question, but
No, you're fine. You're fine. Yes, they should be the same. Well, they will be the same type of problem, but the
well, the
numbers
numbers
probably
will be
change.
same. So I'll have to solve each question again.
Yes. Uh-huh.
Damn. Well, I'll send you the email with the questions I have about the problems, and hopefully I can get some course credit.
Okay. Sounds good. Sounds good.
That was all I had to ask.
All right. And like I said, you know, there's nothing wrong with those questions. So trust me, a lot of people have those same questions, man. They're not dumb questions. They're fine. All right. Anybody else? Anything else before we close out today? Anybody? All right. So as always, try the stuff out. See if you know, you get stuck on anything. Always feel free to ask questions. And other than that, I will see you next class.
Professor Tucker,
Yes, sir.
I don't have nothing to comment on the class.
Mhm.
Trying to figure out how to use my graphing calculator is the only problem I have.
What type of graphic calculator do you have?
I got this TI-84 plus CE.
Okay. Okay. So you just try. Are you trying to graph on it? What are you trying to do?
You like when they give us the first chapter, chapter 1, tells you how to put in functions. Then they put the little keyboard example up there. And every time I try to do it, I can't do it.
Hmm.
A good reference, just YouTube or
If you Google how to use whatever the name of your calculator is, normally videos will pop up.
all right.
Yeah, try that, and then if not, if that doesn't work, then maybe we need to sit
I
down.
know
I can.
I'm the old guy in the class, and I can't figure this. I
I have the same calculator as you, so if you want to like email me or something, I can help you through like how to use it.
Thank you. I appreciate it.
That's
I'll
cool.
put the email in the chat.
I didn't hear you.
She said she'll put her email in the chat. All right.
Hold on.
Professor, I got a question.
Yep.
I said it in the chat earlier, but I don't know if you saw it. I sent an email to you with my scratch work for the test.
Mm-hmm.
Did you get it?
Let me see. When did you send it?
Before class.
Okay,
Like
well,
an
I
hour or
haven't
so
looked.
ago.
Yeah, I haven't looked yet. So let me see. That last name was what again?
Ventus.
Into,
Ventus.
let me see. Let me type in because I don't see it. Mm-mm-mm.
See you later, Professor.
All right, man. You have a good one. Oh yeah. Now, so did you see the email that said that I didn't see anything attached to the email that you had sent me before?
Yes, and I saw a little link down there with your email, and I tried clicking on it and then going through regular like Apple email
Yeah, I didn't
to
get
see if you would.
anything from you since then. Yeah. And so have you tried just emailing me straight, just vtucker@tcc.edu?
Let me try that.
Yeah, let's try doing it that way and see if that'll. Okay, let me stop this recording.